Alright, so for number 20, we have 200 shoppers at the mall. So therefore I know that my sample size is 200 and I can put the total here. And they were asked two questions. Did they see an ad and did they shop at the store? So answering questions on probability for this, for letter A, what is the probability that the person selected saw the ad? So that would be your total from the entire column of, or entire row of saw the ad. So that's 125, and that's out of a total of 200, so therefore 5/8 or 0.63. For letter B, what is the probability that the person selected saw the ad and shopped at store X? So saw the ad and shopped at store X was 100 of them out of 200, so therefore that is half of them. For letter C, find the probability that the person shopped at the store X given that the person saw the ad. So again, that is the probability that the person shopped at store X given that they saw the ad. So you're going to do the probability of shop and saw. So the probability that they shopped and saw is 100, so there's your 100. And that's out of 200, but again, that 200 is going to cancel on the bottom, so you really don't even need to write it. Over the probability that they saw the ad, and that was again 125 of them, so 100 out of 125 is 0.8. For letter D, what is the probability that the person selected shopped at store X? So the total amount that they shopped at store X was 125, so that's the same. And then you are looking to see if the events are independent. So therefore you can either do shopped at X and saw ad, or saw ad given shopped at X. Excuse me, I said and the first time. Now you're looking to see if that probability is the same as whatever event is you're looking for. So in this case, if I do shop at X given they saw the ad, I'm looking to prove that it equals the probability of shopping at X. So shop at X given they saw the ad, which I already really calculated was 0.8. Is that the same that they shopped at X? And we again already did that probability of 0.63. And again, you have to show this, you have to show the probabilities, and you have to show whether or not they are equal. And you also have to have the statement. So you have 1, 2, 3, 4 steps that you have to show for the independence, or else you will lose points. For letter F, are the two events did not see the ad and did not shop mutually exclusive? Meaning disjoint. Again, those are the same words, disjoint and mutually exclusive. So disjoint would be that there are two separate sets. Not disjoint would mean that there was some overlap in between. So you have to ask yourself, is it possible for you to have not saw the ad and shopped at X? And the answer is yes. You could have not seen the ad but still shopped at the store. So here you go, did not see the ad, shopped at the store. There were 25 of those people. So therefore you would say no, there's an overlap between the two events, which in this case is 25. For number 21, a country club president would like to know how many of his members regularly use the golf course and the tennis courts. A survey indicates that 70% regularly use the golf course and 50% use the tennis courts, and 15% use neither. So again, you have 70 for golf and 50 for tennis, excuse me. If you add those up, you can see that 0.7 plus 0.5 is definitely more than 1. So therefore you know that there is definitely an overlap here. In this case, in order to find that overlap, you have to do calculate and. So what's the intersection, golf and tennis? So you multiply the two probabilities to get 0.35. In order to find if the probability that they use the golf course or the tennis course, and again that's the right side up view, I have to subtract out that overlap, so I get 0.85. And then finally the probability that they use the golf course given they already use the tennis court. Again, tennis and golf divided by just the probability of tennis. Tennis and golf is 0.35 divided by the probability of tennis, which is just 0.5, and you get 0.7. For 22, your sample is, or your sample set is A, B. Events A and B are not mutually exclusive, meaning that there is an overlap between them. So it looks like this. Event B occurs with a probability of 0.4. The conditional probability that A occurs given... Alright, so the conditional probability that A occurs given B occurs is 0.5, while the conditional probability that A occurs given B does not occur is 0.2. So you're looking for the conditional probability that B occurs given A. So again, this is really what you're looking for right here. Okay? So you need the probability of A and B over the probability of A. Now, just kind of ignore this for a minute. What you are given is you're given the probability of B, you're given the probability of A given B, and you're given the probability of A given B complement. Okay, those are all of those numbers from the problem. So now, what is a way that I can get A and B with this information? Well, you could use the probability of A given B in order to find the probability of A and B, which is 0.2. So if you go through this process, that's where you're going to get the 0.2 from. Okay? Now, as far as getting the probability of A, in order to get the probability of A, you have to take the probability of A and B, the probability of A and B complement, in order to find that, because the two of those added together is going to give you the probability of A, because it'll kind of take out that overlap of B. So in order to do that, you're going to take 0.4 times 0.5, which you know, 0.4 times 0.5, A and B, plus 0.6 times 0.2, and you're going to get 0.32. So that's how you get this probability of A here on the bottom. Divide those and you'll find the probability of B given A. Okay, 23, last problem, deals with a triple Venn diagram. So you have to fill in the things that you know into your Venn diagram, so it should look like this. So again, 55% adults drink coffee, that's all the whole circle. 25 drink tea and 45 drink cola. 15%, 5% drink all three. So 15% drink coffee and tea. Coffee and tea, you have to take the 0.15 minus 0.05 to get 0.10. Do the same thing with all the other sections. So what percents drink only cola? Here's your only cola, that's 0.15. None of these beverages is going to take all of these and add them together, and you get 0.8, so that means 1 minus 0.8 is 0.2. Alright, so some things that you definitely want to be careful of with probability is, first of all, you want to make sure that probability is always between 0 and 1. If you get a number that is not between 0 and 1 for a probability, you've done something wrong. Make sure you go back and check that. You have to know the difference between union and intersection. Whenever you see a union, that is going to be an or. Whenever you see an intersection, that's going to be an and. Okay? Or means that you add, and means that you multiply. For and events, they must be independent. If the events are not independent, then you cannot use the multiplication rule. For or, if they are not mutually exclusive, or if you have an overlap here, you have to add and then subtract out the things that are the same from the overlap. Okay? I'm also going to go ahead and post on Edline the homework assignment checks so that you can also check those as well. Have any questions? Make sure you see me.